So in this class, I want to derive the mirror formula for concave mirror as well as convex mirror. We already know the mirror formula and we solved lot of numericals based on this mirror formula in our class 10 course. But here we have to derive the mirror formula. It is required in HS second year, and this derivation alternately comes in the exam. Okay? So in order to derive the formulas, we require the convention, sign convention. Lot of conventions are there. Real is positive convention is there. RP sign convention. If the image is real, image distance, positive. If the image is virtual, image distance is negative. There is one type of convention. But here we have to consider the NC sign convention. NC sign convention. N for new Cartesian sign convention. Here all distances are measured from the pole of the spherical mirror. Okay? Distance measured against the direction of incident ray taken as negative, otherwise positive. That means if we measure the distance against the direction of incident ray, that distances are taken as negative, or if we measure the distance from the pole along the direction of incident ray, they are taken as positive. All distances measured perpendicular to the principal axis, perpendicularly upward the principal axis, taken as positive, and all distance measured below the principal axis, taken as negative. Okay? So what is the first formula? The first formula is a real image formed by concave mirror. The real image formed by the concave mirror. So this is the concave mirror, this is the focus, and this is the center of curvature. So PC is the radius of curvature and PF is the focal length. We know that R is equal to twice F. Therefore, when we draw the diagram, so this condition should be satisfied. That means CF must be equal to PF. My object is AB, which is perpendicular to the principal axis, or this is called an extended object. AB is an extended object perpendicular to the principal axis. The first ray I consider AM. It is parallel to the principal axis, and after reflection from the concave mirror passes to the focus along the direction MFA. The second ray approaches towards the pole and then gets reflected along the direction PA following the laws of reflection or obeying the law of reflection. That means this angle is equal to this angle. The second ray AP approaching towards the pole gets reflected from the mirror along the direction PA obeying the law of reflection. That means APB becomes equal to A''PB. These two angles are equal. Angle of incidence is angle of reflection. Now the reflected rays MA' and PA', they are converging ray. Therefore they intersect at the point A'. So if I draw a normal A''B' over the principal axis, then this A''B' is the real inverted image of AB. Real inverted image of AB. In this case, our image found to be magnified with respect to the object AB. Because here object is between the focus and the center of curvature, and image is beyond the center of curvature. Already আমি ক্লাস 10ত পাইছিলো যে when object is in between focus and center of curvature, position of the image is beyond the center of curvature, real, inverted and magnified one. Okay, now we want to derive, now I want to derive the mirror formula. Now I want to derive the mirror formula. So first I take APB similar to triangle A', You just see APB similar to the triangle A', They are similar triangles. Why? Because this angle and this angle equal. This is the common line. Therefore, APB similar to A', Okay. Then I take the triangle MFM' and A', This angle and this angle, these two angles are opposite angles. You just see this angle and this angle opposite angles. Therefore, these two triangles MFM' or A', they are similar. What is MM'? I draw it a dotted line. This MM' and AB, they have the equal size, equal height, because this line is parallel to this. So since MFM' and A', they are similar, MM' by A', you just see MM' by A', is equal to M' by B'. Okay. Now, in the next step, you just see what is MM'? MM' is equal to AB. MM' and AB are equal. Therefore, instead of MM', I have written AB. AB by A', B' is equal to M' by B'. Okay. Now, from these two triangles, you just consider, from equations 1 and 2. You just consider from the equations 1 and 2. AB by A', B', AB by A', B'. Left hand side is exactly same. Again, one consideration is here. If the aperture of the mirror is very small, if the aperture of the mirror small means if this size is small, then what happens? This ray AM comes very close to the principal axis. Sometimes, instead of saying the aperture of the mirror small, we may also say that for the paraxial ray means this light is very close to principal axis. If the ray is very close to principal axis, then what happens? M point will be somewhere here, so therefore M' is almost equal to P. Therefore, I have written, if the aperture of the mirror is small, M' F is equal to PF. You just see M' F. M' F is equal to PF because M' then comes very close to P. So therefore, in the second equation, AB by A', B' is আগতে কি আছিল M' F by B' F আছিল. Instead of M' F, we can write PF. This is equation 2. From equation 1 and 2, we can write PB by P' B' is PF by B' F. PB by PB' is equal to PF by B' F. Have you got it? PB by PB' is equal to PF by B' F. Now here, again one consideration is there. What is B''F? We do not know what is B'. This is the B''F. In the mirror formula, in order to derive the mirror formula, we have to consider the convention. Whatever be the convention, whether it is RP sign convention or new Cartesian sign convention, jitu convention ami ইয়াত discuss korim. In all the conventions, all distances are measured from the pole of the mirror. So if the all distance has to be measured from the pole of the mirror, what is B''F? B''F can be written as PB' minus PF. What is B''F? P''F is equal to PB' minus PF. Okay? So therefore, instead of B''F, I write PB' minus PF. Now, this is the equation 3. You just see the equation. So this is the equation. PB. What is PB? PB This is the PB. This is the direction of incident ray. So what is the direction of measurement? This is PB. We measured PB opposite to the incident ray. Therefore, PB is minus U. What is PB dash? This is PB dash. This is the direction of incident ray. In order to measure PB dash, we have to move against the direction of incident ray. Therefore, this is minus V. What is PF? This is PF. Again, to measure PF, I have to go against the direction of incident light. Therefore, PF is negative, minus F. In order to measure AB, I have to move above the principal axis. Therefore, AB or height of the object is positive. In order to measure B dash A, I have to move below the principal axis. Therefore, height of the image is negative. Okay? So, you just see, according to sign convention, PB is equal to minus U. PB is equal to minus U. PB dash is equal to minus V. Have you got it? And PF is equal to minus F. So, therefore, if I put in equation 3, what is equation 3? What is equation 3? It is PB by PB dash, and minus U by minus V is equal to PF minus F by minus V minus F. Minus U by minus V. So this minus get plus. Cross multiply it, we are getting this. We arrange the equation. Dividing both sides by U, V, F. What we get? 1 by V plus 1 by U is equal to 1 by F. This is the mirror formula for concave mirror producing the real image. Now, what is linear magnification? Linear magnification is height of the image by height of the object. What is height of the image in my diagram? A dash B dash by AB. You just see A dash B dash, it is the height of the image. AB is the height of the object. Yes or no? So therefore, what is linear magnification? A dash B dash by AB. According to equation 1, what is A dash B dash by AB? OB dash by OB. What is OB dash? Image distance. What is OB? Object distance. Not OB, it is actually PB. Sorry. It is PB. So A dash B dash by AB is PB dash by PB. What is A dash B dash? Minus H side, height of the image. What is AB? HO, height of the object. What is PB dash? Minus V. What is PB? Minus U. That means magnification is HI by HO is minus V by U. So this is the magnification formula for concave mirror producing real image. Okay? Now we want to concentrate or we want to derive the mirror formula for concave mirror producing virtual image. For concave mirror producing virtual image. Okay? Now we want to discuss the concave mirror producing virtual image. So you just see concave mirror producing virtual image. So we know that in order to get virtual image by concave mirror, the object should be within the focus of the concave mirror. We already get it in class 10. When object is in between focus and pole, the image formed by concave mirror is magnified and virtual. If the image is virtual, that image is always behind the mirror, concave mirror. It is always behind the concave mirror. So AB is the object. It is in between the pole and the focus. The first ray AM parallel to principal axis after reflection passes to the focus. Second ray approaching towards the pole gets reflected in this direction. I can say this direction is A dash. Get reflected along the direction P A dash. Now this ray MF and P A dash, they are diverging ray. Therefore, they appears to come from A dash. That means A dash is the virtual image of A. I draw a normal A dash B dash over the principal axis. So A dash B dash gives you virtual magnified erect image of AB. Okay, now as previous, we considered a two triangle. What are the triangle? APB is similar to A dash PB dash. Why they are similar? Because these angle and these angles are same. Angle of incidence is angle of reflection. You just see APB similar to A dash PB. They are similar. And these angle and these angles are opposite angles. These two angles are opposite angles. Therefore, APB similar to A dash PB dash. So therefore, we can write AB by A dash B dash is PB by PB dash. Okay, second, MFM dash. What is MM dash? MM dash, we draw a line. I draw a line MM dash perpendicular over the principal axis. These MM dash and AB, they have the equal height. MM dash and AB, they have the equal height. MFM dash is similar to A dash FB dash. They are similar. Therefore, M dash by A dash B dash is M dash F divided by B dash F. You just see. M dash by A dash B dash is M dash F by B dash F. But what is M dash? It is equal to AB. Therefore, in the next line, instead of M dash, I have written AB. Okay? Again, if the aperture of the mirror is very small, then what happens? M comes here. If M comes here, or if the ray AM is very close to principal axis, then what happens? M dash, this point M dash comes very close to P. This point M dash, have you seen M dash? This point M dash comes very close to P. Okay, therefore, M dash F becomes equal to PF. Therefore, AB by A dash B dash, this equation becomes PF by B dash F. Now, from equation 1 and 2, you just see left hand side AB by A dash B dash. This is PB by PB dash, PF by, okay, PF by B dash F. But what is B dash F? All distance has to be measured. B dash F is this. All distance has to be measured from the pole. So B dash F is PF plus PB dash. So therefore, here I have written B dash F is PF plus B dash, PB dash, PF plus PB dash. This is P. PB dash. PF plus PB dash. Okay. Now, from equation 1 and 2, what we get? PB by PB dash is PF by PF plus PB dash. Okay. Now, what is PB now? What is PB now? Just a minute. What is PB? You just see, according to convention, what is PB? What is PB? This is PB. PB means object distance. In order to measure PB, I have to go, this is the direction of incident ray. I have to go opposite to the direction of incident ray. So PB is minus U. What is PB dash? This is the PB dash, image distance. In order to measure PB dash, I have to move along the direction of incident ray. Therefore, PB dash is plus V. In order to measure focal length PF, I have to move against the direction of incident ray. This is the direction of incident ray. This is the distance of, this is the direction of PF. Okay? So therefore, focal length is negative. Again, AB is above the principal axis. This is positive. Similarly, A dash B dash is also above the principal axis. It is positive. It is HO, height of the object. It is HI, height of the image. So if I put this situation according to NC sign convention in equation 3, what we get? Minus U by V is equal to minus F divided by minus F plus V. Now if I cross multiply, I will get this equation. Okay? Now I will get this equation. Have you seen it? I will get this equation. Okay? Now, if I multiply both, if I divided both sides of this equation by UVF, if I divide both sides of this equation by UVF, what we get? What we get? We get this part. We get this part. 1 by V plus 1 by U is equal to 1 by F. Again, what is linear magnification? Height of the image by height of the object. So A dash B dash by AB. According to equation 1, A dash B dash by AB is PB dash by PB. What is A dash B dash? It is H side. It is positive because A dash B dash is above the principal axis. What is AB? HO. It is also positive above the principal axis. What is PB dash? It is positive plus V. What is PB? What is PB? It is minus U. Therefore, M is equal to H psi by HO is equal to minus V by U. Okay? Minus V by U. So, this is the magnification, expression of magnification. This is the expression of magnification for concave mirror producing Parseval image. Okay? We already know that when object lie in between focus and the pole, it gives magnified erect and Parseval image. When image is Parseval, it is always behind the mirror. Okay? I think in class 10, we discussed about the difference between real image and Parseval image. Real image can be touched with the help of our hand. Yes or no? Real image can be placed over the screen, but Parseval image cannot be touched. It cannot be placed over a screen. Okay? Real image is always in front of the mirror. Parseval image is always behind the mirror. Okay? It is always behind the mirror. Today I stopped here.